Okay, we are recording.
Okay, so 235, I'll just randomly pick that number and let's do something in the 30s. 30. Okay, so we were looking at some different ways to multiply. There were three of them. There was the Egyptian algorithm, the Russian peasant method, and what we call the Lax method. So the Egyptian algorithm. Oh, just by the way, real quick, what is this? I've been on the calculator. I'm sorry?
8695.
8,695. So the Egyptian algorithm. What I want to do is I'm going to put a 1, and then I'm going to take the larger. And you can do it by taking the smaller of the two factors, but it's going to be quicker if you take the larger. All right. Now, all we're going to do down each column is double. Double, double. So I want some arithmetic help here. Again, for the left column. 235.
470.
470. Double again. 4. Double here. 940. Double again. Double again. 1880. 80. Double again. 16. Double here. 3,000. 3,000.
760.
376. Sometimes it might have to. All right, one more time. I'm going to double again. That's going to give me what, 32. Going to double here. 20. Okay. So I'm going to stop there because I got a hunch we're going to be able to get this other. What I'm going to now do is I'm going to go down the left-hand column and look for a combination of these that will add up to be what, 37. So say, well, we need this one. That's 32. I have a top 235. So I need what? I'm sorry, I need what? You need the top one there because you have to have 5. Yeah. Okay, I do. So 32 plus 4 is what, 36? And then plus 1 is what? 37. Is that how you always decide? Every time. What combination of these will add up to be the other factor? That's why I said you can start this by putting the smaller factor here, but then you would need a combination of these to add up to be what? 235. It's going to take long. So I want to go this route. And then these three numbers here, 235 plus 940 plus 7520 should add up to be 8,695. Again, referred to as the Egyptian algorithm. All right, now, and the kind of cool thing about this in terms of, I don't find it's the most practical way to do it, but what use does it have if I'm trying to teach multiplication? What it is, it's what? Repeated addition. That's what multiplication is. And so, when you're teaching 3 times 5, what am I saying? Oh, I'm what? 3 groups of what? 5. 5 plus 5 plus 5. Or what? 5 groups of 3. Add 3 with itself 5 times, then you either way you get what? 15. And that's when you actually can start then talking about commutativity. That what? Either way you get the same answer, but 15. And so when you first start teaching multiplication, that's what you're doing. You're repeated addition. And eventually you move to what? Memorizing multiplication. Because you don't want to have to do repeated addition every time. Now, coming back to this one, oh, that's 1 group of 235. That's 4 groups of 235. That's 32 groups of 235, or what? That's 37 groups of 235. So Russian peasant. So this time, you're gonna put both numbers there. Instead of the 1, you're gonna put the 37. And here, you're gonna put the 235. Okay. And so what we're gonna do now, we're gonna still double down this left-hand side. But here, we're gonna cut it in half, which means divide by 2 and ignore remainders. So that's all we're gonna do. We're gonna say 37 divided by 2 is 18. Wait, what is that 18.5? But we ignore the remainder of 1. And we double here, and we've already got it written down, so I can put 7. Cut this in half, and I've got what? 9. Double, I've got 9/4. Cut this in half, and now what, 4? Or the remainder. Double here, 18/8. Cut this in half, would be 2. Double here is 3,760. Cut this in half is 1. And double here is 7,520. Now we already know that I add this one, and this one. Get our product. And so how do I know which ones to pick here? Notice the entries here are the only ones that are what, odd. All the ones I didn't use are what, even.
Always on.
Always odd.
Always on.
You're looking for the odd entry down the left column. That is it. All right. Good there?
This last one was one that really.
Okay, so this last one is the practical. This is the one that I would definitely use in the classroom, particularly for a student who is struggling with the normal algorithm. A lot of times it's just they're not getting things lined up. They forget to put the 0 placeholder in, so on and so forth. So what I do is I construct a box. Now the size, dimensions of said box, rectangular box, is totally determined by the 2 products, 2 factors.
What do you call this?
Lattice method.
Lattice.
This is the lattice. And it just gets its name simply from, looks like lattice. Now, what I do is, since this was 2 digits times 3 digits, across here, I've got slots for 3 digits. Here, I've got slots for 2 digits. If it was a 3 digit times a 3 digit, I'd have what? 9. And put in 2 factors, 235 and 37. Now, in each of these squares, I put a diagonal from bottom left up to upper right. Just like that. Okay. Yep. So, like I said, it is not new. It's not new math, but like I said, it's been around at least in the 1800s. So 19th century. Probably even a little older than that. But still gets used. Now, all we're going to do from here is real simple. This is again what I like about this for the student who handwriting is not that good and struggles just keeping things lined up. This lines it up for me because and I don't have to do the multiply this plus add this as I go through putting in the number. All I got to do is go 3 times 5 is what? 15. 3 times 3 is 9. So in that case, put in an insignificant digit here. 3 times 2 is 6.
Yeah, that's what I forgot. I forgot how.
Put
to show it.
the zero.
Yeah, I forgot how it's supposed to be shown.
So it's just, what I compare it to, when you got to put in especially on, you're filling out something on an online form, you've got to put your birthday. And if you're like me, born in September, then I don't put 09, it's not going to take it. You got to put that placeholder. All right, 7 times 5, 35. 7 times 3 is 21. 7 times 2 is 14. Got all the problems. Now, why does things line up? Get lined up because you're going to add along those diagonals. Now you will carry here as you add them up. The first one's easy. Whatever that digit is, it's 5. Add down this diagonal. 5 plus 3 is 8, plus 1 is 9. 1 plus 9 is 10, plus 2 is 12, plus 4 is 16. So here, 6, carry 1. And then add here, 1 plus 0 plus 6 plus 1 is what, 8. And then, you know, put the 0 here, but you don't need it. And there's your answer. Good? Questions? Any other questions on lattice? Any other questions?
Review division on different bases.
Okay, I can.
I know that's
But-
not something we've done in a while, but
No,
I'm confused.
Okay.
Are you gonna review that like for a final?
Did you work out the homework already and turn that in?
Yeah,
Okay.
yeah.
All right, I tell you what I will do. Because it won't take too long to do it, but it's not gonna be on the final.
Okay.
And so it's not yet, it won't be on the final.
Did that exam had on the binary and I just put it in, I just did it on the line. I'm like, I'm not doing binary today. It was like base 9 to binary. I was like, no way.
Yep, and that's, then in that case, if you have to go base 9 to binary, you have to go through base 10, you don't have a choice. But in terms of division and other bases, I won't, operations, I'm not, and so I will go over it again. The biggest thing on that is you set it up like a normal division,
Mhm.
but you build a table. So let's say you were doing, I'm not gonna do the
Yeah,
division
you're
itself,
fine.
just give you a roadmap. So let's say I was doing 26 divided into 181, 181, 465. But these were both base 9 numbers.
Okay.
So base 9. Now,
This is.
and I wouldn't even ask you to do this, what you would have to, problem is you can't multiply in your head in base 9. And that's what makes this a little bit more difficult. So before you start the division, you have to take each base 9 digit, 0 through 8, 0, 1, 2, 3, 4, 5, 6, 7, 8. And each and every one of them multiplied by 2, 6, base 9, in base 9. Once you create that table, so the first two are always givens, 26 times 0, 26 times 0 is 0, 26 times 1 is 1. 26 times 2 in base 9. That's what, 2 times 6 is 12.
Okay.
But in base 9, because you're multiplying, remember how we did the multiplication, multiply base 10 and convert each time with that base. So we're going base 9. So that's one group of 9 plus 3 ones, or 12 in base 10 is 1, 3 in base 9. So you write your 3, you carry your 1, and that's what 5, 3.
Okay.
Then you write that down on the table, and you do that for every, so you do it times 3, times 4, times 5, times 6. And once you got that table, then you'll know how many times this is going to go into what you're working on.
That makes sense. I could remember I remember you had to do a table, but I couldn't remember what I was.
What the table was in the table. So it's simply whatever your divisor is times each digit of that base. See, when we do base 10 division, we already know. Yeah, figure it out. So, all right. So another question.
Do we have to be able to write down calculator shortcut or what method, whatever?
Do the calculator shortcut,
We need
and
to
we
have it
have
like-
to write it down in
like
the
in the
nested form.
Yeah. I can find it, but I'm not real good at writing that form down, but I know how to get to the answer.
No, you will not have to do that on the time. Now, you will have to do base conversion. You will have. to
Yeah,
convert it
I'm good.
from base 10 to some other base.
I just do it
base
for
10.
one, it's easier.
Now, the shortcut between bases, when there's a power relationship, base 2 to base 16, base 2 to base 8, back and forth there. Okay. Any questions?
I know where I definitely want to start with, just I had asked a question. I can't remember if it was you guys or my Tuesday class.
And everybody was looking at me, like, I don't know what you're talking about.
It's one of those we haven't looked at for a while.
All right, stuff at the beginning.
There you go.
Now, where do we start at the very beginning?
It was geometry.
That's
Wednesday. I'm doing that on Wednesday. So I had that little activity, which is a geometry activity.
Like, side, you're gonna do like side angle, side, all that.
Side, angle, side, angle, side, angle, side, 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 used to what prove triangles congruent. So what I thought we'd look at today is this. All right, let's see, I want to make sure that I'm not reading vacancies. All right, let's say I've got universal set. It's got those are its elements. Small case out alphabet A through I. And then sets the field within this universal set. We'll let this one be A, C, G, set B, it's B, E, F, H, set C. It has A, B, C, H, set D. It's got E, E, F, G. Now I got more sets. All right, I need a couple more sets. We'll do a set E. This is gonna have F in it. Set F. It's gonna have G and H. Okay. So what I'm looking at, this is set operations. So see how much you remember. Let's finish copying down the sets. All right, first one. Want you to find A intersect B. That is, you're finding the elements that belong to the set. So upside down U, remember that means intersection. A intersect B. Okay, so what do I write? That's why I wrote it. What do we call that? The set with no elements.
Empty set.
Empty
but I
set.
don't know what it looks like. Like that.
There you go. Now, so usually, my math lab, that's the symbol they use. And so they would give you the, say, this multiple choice, they would give you the selection, or on the toolbar, there would be that symbol. Now, if you're just writing by hand, this is acceptable as well to represent an empty set. Two braces with nothing in between. Empty set. What was the term we used for two sets that have nothing in common, which means their intersection is empty? Disjoint. So when you hear that term, disjoint, Just means that those two sets or multiple sets have nothing in common, then they are said to be disjoint. Okay. So let's flip it real quick. That is a union B. What would be an A union B here, given these are my sets I'm working with?
About everything.
Everything. Now, when you union, it just means to be in the union, to be in this new set, you either have to be here or here. So I always said, just we're dumping them together in a big hat. So it literally is everything, because for this particular problem, you notice I went every other element. So if you put these two together by union, you have a universal set. Okay.
Is that how we should put it on math lab with that symbol, or do you?
Yeah, they would have that symbol there.
Should, we don't have, like, it won't.
Then they don't put the curly cube.
Like, we won't get, like, if we list them, we'll look at, like.
If you
I don't
list
trust
it,
it,
yeah.
it's so touchy.
Now, bear in mind, I will, if it's like you counted it wrong and you didn't use the U, but you wrote down every single element, I go back and give you credit for it. That shouldn't be an issue. All right, so let's do this time A intersect C. We'll find that. A intersects C. All right. Should have had two elements, A and C. Okay. Now, my math lab is nice because they always give you the braces, and it's just really a matter of them. Okay. B union C. B union C. Okay, so we throw again, everything together. I just wanted to be sure you didn't do one thing. Now, looking at B and C, I would be just writing everything I see in B or C. A, B, D. Oop. You don't have to write in the alphabetical order. My mouth, I wouldn't count it wrong. Remember, the order does not matter. It doesn't make it a new set. But I always try to do it alphabetically. B, F, H, and that's it, right? So we don't write the elements twice or anything, if they occur in both sets. So, all right. Let's do another one. How about, let me do D yet. D complement. What would be in D complement?
Not.
Everything not in D. Everything in the universal set that is not in D. It's everything else. That is complement. So I look at D, it's got what, D, E, F, and G. So I write everything else in the universal set, except what, D, E, F, and G. So it would be A, B, C, skip D, skip E, skip what, F. But then you would have G, H, and what?
You just have-
Yeah.
Oh,
my bad. D, E, F, A, B, C, F, G. And then, okay. Look right at it, write it down. All right. So, right, good there? All right, what else can we do here? All right,
This one I'm not saying anything. See if you remember. Got an in, comma, or parenthesis, in parenthesis, B parenthesis. Not even reading it how it should be read. Wanting to see if you know and remember the notation, what that means. Something very simple. Don't ever think this one. All right. That's got it, pretty sure.
That's it.
Maybe. You got a number?
Yeah.
All right, then you're on the right track. All right, looking for a number, the number we should be looking for is 4. So when you see that, it is read what? Cardinality of B, in this case, cardinality of the set. And it simply means the number of elements in that set. Which in B, there are 1, 2, 3, 4 elements. Cardinality. Good there? Okey dokey.
Isn't there something like subsets and proper?
Oh, yeah, yeah, we just haven't got
I can't
there
remember
yet.
this.
We just haven't got there yet. Yep, okay, but we will. Okay, so we had cardinality here, we've done union, we've done intersection, we have done complement. We have not done this. All right, that one is red, C not B. That's your hint too. What is in the set? C not B. C not B. So this is called set difference. And it's read again, you see this, it looks like subtraction. But it's read C not B. And when I say that C not B, it gives what you're looking for right in that phrase, C not B. I want all these, now, first of all, the elements I write here have to be in what? C. I'm just simply going to take any elements out of C that happen to be in what? B. So I look at these two, and I'll say it looks like, oh, H. It's in B. So, and it's in what? C. So I want to what? Wipe it out. As well as what? B. So since B and H are in B, I take them out, that leaves me with what? A and C. So when you do a set difference problem, look at this and just say, okay, are there any I need to take out? And the ones I take out would be in this set. We good? Set difference. Okay. All right. Let's go see. Here. Let's see how we do on this one. I'm just going to write it down, see how we do. All right. I'll give you 1 minute. You need to look it up. So it looks like multiplication. That kind of looks like F multiplied by E. It is actually read F cross E. F cross E. What would the elements of F cross E be? All right, what does an element in the cross product, and that's what this is called, look like? What, one element, two words, that's it, all right, so you're right on, you said a coordinate pair, just like you were graphing, right? We call it a ordered pair, an ordered pair. And so every element of a cross product, every single element is an ordered pair. And so how do I find these ordered pairs? Now, the order here is important. Cross product is not commutative. F cross E is not the same as E cross F. The reason being is these ordered pairs, the first component comes out of the set on the left. The second component comes out of the set on the right. That's why I threw these last two up here, so you didn't have to write a ton of ordered pairs. So I just put two elements in each. So you would have here, and the order in which you write these ordered pairs does not matter, but I'm just doing it systematically. So I'm going to GE. Next ordered pair will be GF. Next ordered pair will be HE. And last ordered pair will be HF. Four ordered pairs. Now, if I was said find the cross product of E cross F, you would transpose each one of these, and those would be four different ordered pairs. All right. Next one. Find me this. Now, I'm going to forewarn you. I'm not looking for you to find the ordered pairs. I'm asking how many are there. That's all. It's like what cardinality. The cardinality of A cross B. What is it? How many ordered pairs would, so that's all I want to know is how many ordered pairs would be in A cross B? How many ordered pairs in A cross B? Did you say 20? 20 is it. So how did I get 20? There would be 20 ordered pairs. Count up, find the cardinality of each of these two. They cross B in this case. So there are what cardinality of A is 5. Cardinality of B is what? 4. It's 4 times 5 or 5 times 4. So A cross B is not the same as B cross A, but the cardinality of A cross B is the same as cardinality of B cross A. The multiplication itself is commutative, but that's all you're doing, multiplying. Notice this was what? Cardinality of 2, cardinality of 2, 2 times 2 is what? 4. Okay, so now to your question. This one I got to write word to. So how many subsets are there for set A? Looking for a number. Just don't write them all down. You will be there a while trying to do it. You can do it, but you don't want to do it. Just tell me how many of you are. I'll give you a minute though. See if you can remember how to do that. How many subsets are there for set A? Tell by the buttons you're pushing. I think you got it. Okay, fair enough. All right. So here's the number. Assuming my arithmetic is correct. 32.
What I got.
So how did I get 32? What is the cardinality of A? That is how many elements are in A? There are 5. The number of subsets to any set is 2 to the cardinality of that set. And 2 to the, what's that?
I said, I know what I did after you wrote that.
I saw you go up to the power button. I thought I saw you hit the carrot button. That's
I
why.
did, but I did -1, but that's.
Oh, that's proper
subset.
subset.
That's
That
why-
was my next question.
Yeah, I'm
So,
sorry.
no. That's why we're reviewing. The number of, if I had asked, what is the number of proper subsets? So remember what that means is to be a proper subset. It's the same, so when I look at any subset of A, it's all it has to be is a set such that all the elements of that set are in A. So a set can, by that definition, be a subset of itself. So one of the 32 that you are counting as the number of subsets is itself. And so when you ask, what is the number of proper subsets to a set? It's always 1 less than the number of subsets, because the one you're taking away and not counting is itself. So the number of proper subsets. The number of proper subsets. Is then 31. Because that is 2 and then subtract 1. All right. Okay, and these were all the set operations that we learned in chapter 2. I want to make sure everyone's got everything written down that you want written down. So I'm going to wipe the board out so we can do some other set stuff. Now, there is one thing we haven't done here. So before I wipe these out, I'm gonna erase it. There is one more thing. we should do. Find me this set. I mentioned it as okay, so I don't know what's going to be in here. Not B complement intersected with B complement. Go. That is combination of the set operations. So A not D, complement of that intersected with B complement. What would belong to that set? So here, when you approach this, remember, kind of like order of operations, I would first do these one at a time, find A not D. Then take the complement of that, which would be everything not in A not D. Then you would need to find B complement. And then you have to find what's common to both. So go ahead and work on that for, I'll give you a couple minutes. And then I'll work it out. Okay, so let's go ahead and work this one. So again, just like using order of operations, one thing at a time, innermost group and simple, A, not D. So what I write here is I'm gonna put a brace. Now I'm gonna put just the elements that are in A, not D. So I look at D, it's got D, E, F, G. So what would I eliminate? Looks like what? E and what? E and G. So I would write what? A, C, I. Now, so I have the what? Common. And now, if you want, you could go ahead and do this one. What would be in B complement? Well, and you can actually do this if you want. Since B complement is what A, you can just write A, or you can write down all the elements of A, either way. Okay, now I need to write down what everything but what A, C, and what I. So that would be B, D, E, F, G, and what? H. And then intersected with A. Okay, so now I just need what's common between what A and this set. So our look, what is common, it looks like E, G, and that's it. That's all I see common between the two. Do I have that right? Double check. I'm just looking what's common between here and B, D, E, F, G, H. I'm just seeing E and what? G. That's it. And so at the end, it's E and G. Good? Okay. I've got about 15 minutes. What? A. Not C. All right. Now, this doesn't have anything to do with what we were doing over here. I don't know what actually the elements of A, B, and C are. If I have some set A, some set B, some set C. Want to find this. What do I want to do? Shade in a what Venn diagram that would be representative of this set. So I got three sets I'm dealing with, three interlocking circles. Label them. See, what I now do is what shade what is representative. So A intersect B is what this portion right here, but take away what? See. That's it. Remember that? Okay. What's next? We could look at for sets go. Okay, this is from homework 2.4, dealing with Venn diagrams, which is this. We call them survey problems, and yeah, I'm still having a little bit of visual issue. How well can you see that, William?
I can somewhat see it.
Yeah, it's not the best. One of the things I'm gonna have to work on. So I can I've got this up here, but I want you to be able to see the board too. One of the things I'm gonna work out for next semester. We're still doing this. So I'm gonna just turn it back to the board and I will just read out the problem, but it's a survey problem. So let me go ahead and turn this back here. Okay, survey problem. All right, it says a middle school counselor attempted to correlate school performances with leisure interests found in a group of students. That of a group of students, 34 had seen movie A, 27 had seen movie B, 23 had seen movie C, 16 had seen movies A and B, 11 had seen movies A and C, 9 had seen movies B and C, 4 had seen all three, and 5 had seen none of the three. Use a Venn diagram to complete parts A through C. So the first thing you've got to do is fill in the Venn diagram. You see a Venn, they give you the Venn diagram. It's got three sets representing the number of students who have seen movies A, B, and what? C. And so on my math lab, you've got an empty box, a field to put a number in each of the 8 regions. And you go through the information, always go for this middle part first. That is, how many have seen all three? And I look up there and it says what? 4, right? 4 had seen all 3 movies. Then we kind of spiral our way out. Now I'm looking at the number of students who have seen movies A and what? B. So I'm looking here. When I look up at the information, it said what? 16 had seen A and B. So what number do I put here? 12. Because you want a total of 16 in that intersection, that football show. And that's how you begin to separate it out. So let's do B and C. It says 9. So I would need what? 5 more. And A and C says 11. So I would need what? 7. Then I could go out, how many watched A? It says what, 34. But I've already counted, what, 23? So 34 minus 23 would be what? 11. So that everything, all 4 regions added up in A, add up to be 34. Same thing for B. B says it was what? 27, of which I've counted 21. So I would need what? 6 more. And then for C, says there's 23. I have counted 16. So 23 minus what? 16 would be what? 7. And then how many watch none of them? It gives that information. It says 5. And so you put all the numbers in the fields, check it, make sure it says what, good to go. And then from there, we'll ask question, how many saw movies A and C, but not B. And you would say, okay, it would be what? So. Okay. So, so this was just a review over sets. Now, again, I want to put together a homework assignment. That is a review for the final. I apologize, I did not get that done last week. But it will be up either tonight or by tomorrow morning. And then, of course, I want to make sure I have at least one morning, you've had a chance to look at it, if you have any questions. Now, on Wednesday, again, we want to look at geometry and a little bit of the problem solving stuff we did in chapter 1. And I've got that activity I want to do as well. It won't take that long. It's just a good hands-on activity with geometry. It's a little bit of a magic trick. But you guys, again, if you're here, you don't need to bring anything. If you are at home, and I'll send out an email, when I send out the paper, I'll put, you need to print this out and have a pair of scissors available if you're at home virtually to do this. And that will be Wednesday. Also Wednesday, the papers. Again, some of you have already turned them in by email. And so either by email or bring in a printed copy. Otherwise, have a great day. It's a beautiful day out, and I will see you